So good afternoon, everyone. We are Group 2, and our topic for today is all about computation of the sun at different times and dates. So, this will be helpful because pwede natin ito ma-apply pag maglalagay tayo ng overhangs or if we want to control the sun's shading in our building. So, our first reporter is Kristine Mae Cabarle.
We start to learn how to calculate the sun angles of different times and date. Ano nga ba ang sun angle? Sun angle is the angle of incidence at which sunlight strikes the earth at a particular time and place. In most places, the sun rises in the morning, is highest at noon, and sets in the evening. In different seasons, the sun is farther north or south. The angle controls the amount of heat energy received at this time, so summer days are usually warmer than winter. Next. So this is the illustration of the summer and autumn, spring, and winter angle. So how high is the sun above the horizon, and does it change from season to season? Next slide. Next slide po. So the height of the sun above the horizon varies with the season. As we can see here in the illustration, the north hemisphere summer path is high above the horizon, and the winter path is lower than the summer path horizon. So the apparent path of the sun does change from season to season. In June or the summer, the sun is high above the horizon. In September, it is lower, and in December or the winter, it is very low on the horizon. Next.
Here are the 5 easy steps to measure the angle of the sun above the horizon. You just measure the length of the shadow of the object. Here's how. First step is to pick a vertical object that is easy to measure and relatively permanent, such as a sign post or a fence post. Number 2, measure its height and write it down. The third step is right at noon on a bright sunny day, measure the length of its shadow on the ground. The next step is to take the vertical measurement and divide it by the shadow measurement, P divided by A. The result is a tangent of the angle. Using a scientific calculator, you can look the tangent of the angle of the shadow. Here is the illustration po. Yung yellow na nakatayo is the sign, post, or fence na gaganito. And B is the height of the fence. And A is the measure of the shadow created by the sun. And ipag-divide sila, B divided by A. And then using calculator naman, saka natin makuha yung tangent nila.
Okay, let's pause for a minute. So now, as you can see guys, tapos na ba ninyo yung trigonometry ninyo? Meron ba kayong trigonometry? Ito na sumasagot. Di ba may trigonometry class kayo ng first year? Tama ba?
Yes po.
Okay. So now, you see, there's a reason why, no? Kung bakit kayo nag-aaral ng trigonometry. And this is one of those, no? Trigonometry. No? Ano tong ano yung angle na yan o na nanggagaling sa sun para ma-compute nyo yan, no? You have A, you have B. What is that? Normally sa trigonometry, ano yan? Ano sa triangle yan? So, review ng trigonometry. So, as you can see, no, lahat ng pinag-aaralan natin ay connected as I've said to you before. So, this time, para kung gusto nyo talagang i-master ang tropical design to your designs, you always measure the angle of the sun. So we have this, may measure nyo kung gaano ba kalaki yung shadowing na ma-achieve ninyo on a certain time. Sorry. And to your techniques, no? Kung this time meron kayong mga sun shading or meron kayong mga canopies and all, or even the eaves of your roof, you can make sure how much the amount of light na po pwedeng makapasok sa inyong building, or how much ang amount ng shade na po pwede nyong ma-achieve, no? So this is like a triangle. Alam niyo yung hypotenuse sa trigonometry. So patay tayo dyan, no? Hindi niyo masagot,
Yung
ha?
hypotenuse po is the longer side of triangle.
Okay, di ba? So, yung B, pwede nyong ma-measure niya dahil yan yung inyong possible na pwedeng i-design na, let's say you have a fence or you have a certain wall or canopy, let's say, no? So, on a certain time, you can calculate the right angle or the correct projection of your sun. So, kaya basic lang dapat trigonometry, alam nyo di ba? Kaya yung mga medyo mahina sa trigo dyan and algebra, nako, kailangan nyo nang mag-review, ano? Habang tatagal kayo sa architecture, gagamitin nyo yan. Lalo na pag kayo ay meron ng structural analysis. Or sorry, mga architectural math, no? Yan ang inyong foundation. Sige.
Here on this slide. So here's how we can compare the sun's height for the different seasons. We can make a measurement on a sunny day near the summer solstice or the winter solstice. And again, the summer solstice is the longest day of the year in the northern hemisphere. On the other hand, winter solstice, the shortest day of the year in the northern hemisphere. Next slide. To compare the sun's height for different seasons, we can use a method called solar altitude. And this involves using an angle, a device called sextant and clinometer. Yung nasa left yung sextant. Para siyang telescope where sisilip tayo dun and dun natin determine yung angle. Yung nasa baba yung angle. Tapos sisilip tayo dun. Kung makita natin yung sun day, dun natin determine sa baba yung angle na sa liwanag yan. Okay, next. Here are the steps on how solar altitude measurement can be done. First is choose a sunny day near a summer solstice and a winter solstice. The reason for choosing these dates is that they are the points in the year when the sun angle in the sky is at its highest and lowest. By measuring the sun's altitude at these times, we can get a sense of the sun's height changes over the course of the year. Second is find a level and open area with an unobstructed view of the horizon. To get an accurate measurement, we'll want to choose a location where we can see the horizon clearly in all directions. So dapat walang obstructions, walang puno, walang anything else na makakaharang dun sa sunlight. This can be a flat rooftop, a hilltop, or an open field. Third is hold a sextant or clinometer level, yung devices kanina, and sight the sun through the instrument's telescope. Next slide. The fourth step is note the angle displayed on the instrument's scale or readout. As we look through the telescope, we should be able to see the sun in the center of the viewfinder. The instrument will display the angle between the sun and the horizon. This is typically in degrees, yung kanina sa picture yung nasa ilalim ng sextant. The fifth step is repeat the measurement at the same time of the several for the several days around the solstice. To get more accurate measurements, we should take multiple readings at the same time over the course of several days. This will help to account for any variations in the sun altitude due to changes in the Earth's position. Lastly, the last step is compare the result for the two solstices to see how the sun's altitude changes with the season. Once we have taken measurement for both summer and winter solstice, we can compare the results, the data we gathered uh, over the year. Typically, we will have to find we will find that the sun's altitude is highest in the summer and lowest in the winter, reflecting the tilt of the sun's axis relative to the sun. Next. We can also make shadow measurement on the equinoxes. Again, yung equinox, it is the times in the spring and fall where lengths of days and nights are equal. By making these measurements and recording them in a journal, we can create a sun path model that shows the path of the sun across the sky through the year. This is helpful for us architects, architecture students, engineers, and designers who need to consider the impact of the sun's position on our projects.
So, if you want to compare the sun's height for different seasons, here's how. First, write down your measurements and put them in a place that you won't forget. Then, you will wait for the seasons to change until you can make another measurement. So, when you have at least a winter shadow measurement and a summer shadow measurement, you're ready to do the math and discover how the height of the sun changes in the sky. So, if you're done measuring daw, take note your measurement and put them in a place that you won't forget. So, kasi you will wait for the other seasons to change until you can make another measurement. So, for example, here, we will show you how to compute the sun's angle. So, here is the formula. Tangent theta is equal to B divided by A. So, B is equal to the height of vertical object, which is, for example, 3 cm. So, yung shadow ng object na to is 2 cm. So, we have to substitute our values and then compute it. So, tangent theta is equal to 3 divided by 2. So, this is, if you type sa scientific calculator, you will get 56.3 degrees and yun yung magiging angle ng sun mo. So, ayun. And thank you for listening, and once again, good afternoon.
So I guess they explain it well, no? Just take note of all the things. Can you go back to the slides? First ones. Ayan, sige. Pakita nyo yung kanina. Yung sinasabi nating trigonometry. Okay, next. Next. Yan. Di ba trigo yan? Yung mga huminga ng malalim na pumasa sa trigonometry dyan. Sorry to say, no? Makikita nyo pa rin ang mga sine, cosine, no? Yung mga scientific calculator nyo, nasa inyo pa ba? Or meron na ba kayong scientific calculator? I'm just laughing now because it also reminds me, no, na these are the things na akala natin tapos na, pero hindi pa pala. So, merong mga paggagamitan yan. So, kung kayo ay familiar na sa trigonometry ninyo, you see how it's being used in a different way. No, this is now the actual way of measuring the sun. Alright, so that's the conclusion. Okay, thank you, Group 2.